Hey mathematicians, here are your notes for section 1.4. We're going to be talking about solving absolute value equations. So the absolute value of a number, I'm going to shorthand here, absolute value of a number is its distance from 0 on the number line. Since distance is non-negative, the absolute value of a number is always non-negative as well, aka it's positive. We use the symbol of two upright parallel bars to represent the absolute value of a number x. When evaluating expressions, absolute value bars act like a grouping symbol. We have to simplify inside of the bars first if possible. We always want to isolate those as well. So for our first example, we just have an evaluate. It says evaluate 1.4 plus the absolute value of 5y minus 7 if y is equal to negative 3. So we have a number we can plug in for our variable. Let's go ahead and do that. Oop. That's a negative 3 right there. Minus 7, absolute value. We're going to do what is inside of those absolute values first, just like it says up here. So we get negative 15 minus 7 in absolute value. This becomes negative 22, but the absolute value bars tell us it's the distance from negative 22 to 0, meaning this is 22. Now that we've done the inside, we're going to keep pulling that down. 1.4 plus 22 is actually 23.4. And there's our final answer. Just plug and chug there. So, some equations contain absolute value expressions. The definition of absolute value is used in solving these equations. So, when we solve the absolute value of x minus 5 equals 10, we first have to look at what our solutions could be. What are the numbers that could go inside of our expression that would give us a result of 10? Well, the absolute value of positive 10 would equal 10. The distance from 10 to 0 is 10. However, we could also get an answer of negative 10 in our absolute value because the distance from negative 10 to 0 is also 10. So because we can have a positive or a negative inside of our absolute value, we actually have to set up two equations in order to solve our original. Since we know that a positive 10 could go inside, we say x minus 5 could equal positive 10, but x minus 5 could also equal negative 10 because either one of those answers would give us a result of positive 10 in our equation. Once we have our two sides, we're just going to go ahead and solve. Add the 5 over, we get x equals 15. Add the 5 over, we get x equals negative 5. And then of course it says check your solutions. We have to be careful because absolute value can be a little tricky. So I plug 15 back in and I get 15 minus 5 is 10. Absolute value of 10 is 10. Check, that one's good. Negative 5 minus 5 is negative 10. That becomes a positive 10. That one's also good. Let's box those answers, make it really clear, and we're done there. But remember how I said they're tricky, and this is why. This problem says solve the absolute value of 2x plus 7 plus 5 equals 0. So like I said before, we want to isolate that absolute value and then eliminate it by creating two new equations. So I'm going to isolate it right away by moving that 5 to the other side. When I do this, I get the absolute value of 2x plus 7 equals negative 5. Except right here, we should have some red flags. The first red flag is that an absolute value cannot be negative. We already said that distance is non-negative. So how can this number of an absolute value result be negative? It can't be. And that's what this down here says. Because the absolute value of a number is always positive or always non-negative, or 0, an equation like the absolute value of x equals negative 5 is never true, and thus it has no solution. So when we're solving absolute value equations, we have to be really careful to stop at this step. As soon as our absolute value is isolated, we need to check our result and make sure that it doesn't cause any problems. If it does, there's no solution. All right, example 4. Solve the absolute value of m plus 3 equals 12 minus 2m. So we've already got our left side isolated, which means we're going to break it down into those two equations that I talked about before. M plus 3 could equal the positive version of this. Sometimes it's easier to think about it all in parentheses. It could equal 12 minus 2m, the positive, or it could equal m plus 3, the negative version. And when I put a negative outside of that parenthesis, remember I'm going to distribute it in so that I get negative 12 plus 2m. Now I've isolated and eliminated those absolute values. From here, we're just going to solve. I'm going to move the 2m over to get 3m on this side. I'm going to move the 3 over, get 9 on that side. M equals 3. Over here, same thing. I'm going to move that over so I get negative m, move the 3 over, I get negative 15, divide both sides by 1. And as always, check my answers. Let's plug 3 back in. So I get the absolute value of 6, so 6 equals 12 minus 6. All right, that one checks out. That is an answer. Let's check 15. 15 plus 3 is absolute value of 18 equals 12 minus 30. That would be negative 18. That one is not going to work for us. This is not a solution. So whenever I get a solution like this, I go ahead and box it to show that it was a possible, but then I cross it out to say it's not an actual solution. So there you have that. Notice we can have 2 solutions, we can have no solutions, and we can have 1 solution when it comes to absolute value. All right, next one. Again, isolate, then eliminate. We divide both sides by 2. We get the absolute value of x minus 2 equals 4. Check this step. Notice this isn't negative. It doesn't cause any problems. So I break it down into my 2 equations. I get x minus 2 equals positive 4. X minus 2 equals negative 4. X equals both 6. And if we add the 2 over, negative 2. Double check. 6 minus 2 is 4. Absolute value 4 times 2 is 8. We're good to go. Negative 2 right here. So that's negative 4. Absolute value makes it positive. 4 times 2 is 8. Those are both good to go. Circle them. And of course, real world application. Why do these absolute values matter so much? Well, here you go. Some say to brew an excellent cup of coffee, you must have a brewing temperature of 200 degrees plus or minus 5 degrees. Write and solve an equation describing the maximum and minimum brewing temperature for an excellent cup of coffee. Well, right off the bat, I know this plus or minus is going to be my solution. I know that my result of my coffee needs to be within that 5 degrees. So, to get the plus or minus, I'm going to start working with my absolute values. I notice I have to say my variable minus 200 because that's talking about the degrees that we care about. Notice if I put my 2 answers in here when I solve, I will get 5. So let's look at why this works. If I isolate, like I already have, and eliminate, I'm going to get x minus 200 equals positive 5. X minus 200 equals negative 5. That's the plus 5 degrees. That's the minus 5 degrees. We indicate that with those absolute values. And notice when I solve, I get that my cup of coffee is either 205 degrees or 195 degrees. That last one can be a little bit hard to read, but anytime you see that plus or minus 5 degrees, that's going to be your result. If you have any questions on this example or anything else I've gone over, don't hesitate to let me know.